Welcome to the Test 2 review session for Developmental Math Combined. This review session is going to go over learning modules 1 through 3, which will be covered on your Test 2, which is now available in the Valencia College Testing Centers. And the deadline is the date that you see on the screen, Tuesday, November 13th, 2018. It's Tuesday and not Monday, which is in the schedule as Monday, because the Osceola Testing Center is actually going to be closed early for a staff meeting. So I extended the deadline to Tuesday just in case anybody was planning to use the testing center at Osceola campus in the evening. I just found out about that closing early last week. And please excuse my voice, I'm a little hoarse, trying to get over a cold, but the show must go on. So we're going to go ahead and get started. Okay, so number 1, evaluate the expression using the order of operations. So let's remember that the order of operations, we like to remember using please excuse, my dear Aunt Sally, or PEMDAS. So the P represents parentheses or grouping symbols. So the first pair of grouping symbols that we see will be the absolute value here. So we're going to do this absolute value first. So within the absolute value sign, we have, -3 minus 1. So you have the same sign, so we're going to add and keep the sign. So we have -7. We have the absolute value of -7. We're still multiplying it by -2. We're going to bring down everything else around it. Okay, so now we still want to work within the grouping symbol of the absolute value. So the absolute value of -7 is +7, because that is asking for the distance that -7 is from 0. So we have -2 times +7 divided by 3 times -2. And so now at this point, we don't have any exponents, and now we have multiplication and division. So those two operations have equal importance based on what comes first from left to right. And then once you take care of any multiplication and division, addition and subtraction have equal weight based on what happens first from left to right. So here we have multiplication, division, and multiplication. So we're going to do this multiplication first. So -2 times 7 is -14. And we have divided by 3 times -2. And then we have -14 divided by 3 times -2. So we're going to do this division first because that's what we see first from left to right. So -14, I'm going to write it like this, divided by 3. And then we have times -2. So a negative times a negative is a positive. And then 14 times 2. 2 times 4 is 8. 2 times 1 is 2. So we have 28 divided by 3. And then that's going to be our final answer. Okay. All right. Number 2, translate the phrase into an algebraic expression. Use x to represent the unknown number. So the product of 4 and a number added to 10. And so they tell us that we want to use x to represent the unknown number. So a number is going to be x. And so now we have the product of 4 and x. So product means we're going to multiply. That's the answer for multiplication problem. So the product of 4 and the number would be 4 times x, which is 4x. And then finally, added to 10, we'll add 10. So the final answer will be 4x plus 10. You could also write 10 plus 4x. That would give you the same answer because addition is commutative. You can move around the values and still have the same answer. Okay, number 3. Evaluate the expression for the given replacement values. So I'm going to write this a little bigger. X squared plus z divided by y squared minus 2z is the negative 2z. Okay, so now we've got x equals 2, y equals, that's supposed to be 3 or negative 3. We'll say that y equals 3. Okay, and then we have z equals 11. So everywhere I have x, I'm going to plug in a 2. Everywhere I have y, I'm going to plug in a 3. And then everywhere I have z, I'm going to plug in 11. Okay, so I'm going to have 2 squared plus 11 divided by 3 squared minus negative 2 times 11. And just so we understand, 2 equals x, 3 equals y, and 11 equals z. So now from here, let's take care of the numerator. So 2 squared is 4 plus 11. And at the bottom, I have 3 squared, which is 9, 3 times 3, minus, in the parentheses here, I have negative 2 times 11, so that's going to be negative 22. Okay, so now 4 plus 11 is 15, divided by 9 minus negative 22. I have minus a negative. That's going to be the same thing as adding the opposite. That's actually going to be 9 plus 22. All right, and so now we're ready to take care of the bottom. So 9 plus 22 is going to give us 31, because if we do that on the side, 22 plus 9, 2 plus 9 is 11, 1 carry the 1, 1 plus 2 is 3. And then we have 15 at the top. And we can't reduce this further. There's no common factor that we can factor out of 15 and 31. So 15 over 31 is your final answer. Okay, number 4. Simplify the algebraic expression. So here we have 9 times, open parentheses, 6x minus 8y, close parentheses, minus quantity 10x minus 7y. So I'm going to distribute this 9 into this parentheses here. So I have 9 times 6x minus 9 times 8y. And then now I'm going to distribute this negative here. So I have negative times 10x, and then a negative times a negative gives me a positive 7y. Okay, so now 9 times 6x equals 54x. Negative 9 times 8 is negative 72y. And then I'm going to bring down my minus 10x plus 7y. And now from here I'm going to combine my like terms. So I have 54x minus 10x 54x minus 10x. Those are like terms because they both have the same variable. And then I have negative 72y plus 7y. And so when I have like terms, I'm going to just combine the coefficients. So here, 54x minus 10x, 54 minus 10 is 44, so it's going to be 44x. And then negative 72 plus 7. So I have different signs, so I'm going to subtract and take the sign of the larger number. So this is a larger number is 72, so it's going to be negative. And if I take the difference between 72 and 7, that's going to give me 65. So it's going to be negative 65y. So my final answer is going to be 44x minus 65y. Okay, number 5. Solve the equation. Use words or set notation to identify equations that have no solution or equations that are true for all real numbers. So to solve this equation, I'm going to start by simplifying each side of the equal sign. So I'm going to focus on the left side. So on the left, I'm going to distribute this 3 in the parentheses. So I have 3 times x, which is 3x, and 3 times 3 is 9. I'm going to bring down everything else. And now I'm still trying to simplify the left side of the equal sign. So I have like terms here, 9 plus 1. So 9 plus 1 is 10. So I'm going to bring down everything else. So I have 3x plus 10 equals 3x plus 2. And now I'm going to move all of my variables to one side of the equal sign and my constants, numbers with no variables, to the other side of the equal sign. So let's say I want to move my x terms to the left. So I'm going to subtract this 3x on the other side. Let's see what happens. So 3x minus 3x cancels out. And so I just have this positive 10 equals, and then 3x minus 3x cancels out again, and I'm going to bring down that positive 2. So all I have left is 10 equals 2. Now 10 does not equal 2. That is a false statement. So this means that there is no solution to this equation. And that is your answer, no solution. Okay, number 6, solve the equation. So I have fractions in this equation, so one helpful strategy to solve these type of equations is to clear out the fractions. And this is how we do that. So we're going to multiply everything in this equation by the least common denominator. So if I look at my denominators, I have a 4 and a 5. So I need to get a number that is a common multiple, or the least common multiple, between 4 and 5. So a way to get a common multiple would be to just multiply the denominators together. And sometimes it is your least common one, and sometimes it's just a common one. Let's multiply them together to get a common denominator. So 4 times 5 equals 20. So if I multiply everything in this equation by 20, I'm going to clear out the fractions. I'm going to show you what will happen. So I have 20 times x over 4 minus 20 times x over 5 equals 20 times 2. So now I have 20 times x over 5. I can actually simplify 20 over 4. So 20 and 4 have a common factor of 4. Okay? 20 is the same thing as 5 times 4. So these 4s, actually, I'm going to write that differently. 20 is the same thing as 5 times 4. And as you can see here, these 4s cancel out. So all I'll have left is 5 times x, which is 5x. Okay, let's look over here. So 20 can be written as 5 times 4, and we're doing that so we can cancel out the 5s. 5 over 5 cancels out. So now all I have left is this negative 4 times x, which is negative 4x. That equals 20 times is 40. And so now 5x minus 4x equals 1x. And 1x is equal to just x, so I have x equals 40. And that's my solution. X equals 40. If there's any questions, please feel free to ask. And number 7, use a proportion to solve the problem. Okay, in a sample of 97 widgets, 5 are defective. How many defective widgets would you expect in a sample of 776 widgets? Okay, so let's see. If we're going to use proportion, let's say we've got defective over sample, total sample. Okay, that's going to be our proportion. Let's look at this first example. So 97 widgets, 5 are defective. So if we're going to use this proportion, defective over total sample, we're going to put 5 over 97. And so we're going to say that's proportional to the same ratio. So remember, it's going to be defective widgets over total sample widgets. So that's this here. So now, how many defective widgets would you expect in a sample of 776? So that's going to fall under this ratio here. So where will we put the 776? At the bottom. And then, how many defective widgets? We don't know. We don't know that. That's going to be our variable x. Okay, so to solve a proportion, you want to cross multiply. So we have 5 times 776 equals 97 times x. And so now we're going to divide by 97 because we want to solve for x. So first, let's multiply 5 times 776. So we'll do that over here on the side. 776 times 5. So 5 times 6 is 30. 0, carry the 3. 5 times 7 is 35. Plus 3 is 38. Carry the 3. And 5 times 7 is 35. Plus the 3, 38. So I have 3,880 equals 97x. Then I'm going to divide by 97 to solve for x. So I have 3,880 divided by 97. Okay, so now we're going to use long division. So I can't divide 97 into 38, but I can divide it into 388. So 97 goes into 388, definitely 3 times. Will it go in there 4 times? I think so. Let's try it. 4. 4 times 7 is 28. Carry the 2. 4 times 9 is 36. Plus 2 is 38. but I wrote 36. 38. So then we're going to subtract 38 minus 38 is 0. We're going to bring down that 0, and 97 goes into 0. 0 times 97 is 0. So we have a 0 remainder. So that means that x equals 40. So that tells us that the answer would be 40 defective widgets if we had a sample of 776 widgets. Okay? All right, let's look at number 8. Another proportion problem. Excuse me. And we're going to round to the nearest tenth. So a building casts a shadow 45 meters long. At the same time, the shadow cast by a 0.46 meter tall pole is 0.57 meters long. Find the height of the building. So we're going to say the height. Let's talk about the proportions. We've got height of the building or the pole, and then we have over the shadow length. Let's see what we've got. Let's take the information that we do have. So the shadow cast by a 0.46 meter tall pole is 0.57 meters long. So that's going to be this first ratio. So if we're doing height over shadow, so the height is going to be how tall the pole is. That'll be 0.46 over how long the shadow is, 0.57. That's equal to, so we've got the building cast a shadow of 45 meters long, so that 45 would go in the denominator. And it says to find the height, so the height is going to be our x. Okay, so now to solve this proportion, we're going to cross multiply. Now remember, we are not using a calculator in this class. You cannot use it on your test. So we have 0.46 times 45 equals 0.57x. Okay, so let's first find 45 times 0.46. So remember, when you're multiplying decimals, we can ignore the decimals, set it up as if they're whole numbers, and then go back and put the decimals in there. So 6 times 5 is 30, carry the 3. 6 times 4 is 24, plus 3 is 27. And then we're going to put that placeholder and go again. 4 times 5 is 20, carry the 2. 4 times 4 is 16, plus 2 is 18. And then we're going to add. So we have 0, 7, 2 plus 8 is 10, carry the 1, 2. So remember, we have 0.46, so we have to go back and put those 2 decimal points in. So we have 20.70 equals 0.57x. And then now we're going to divide by 0.57 to solve for x. Okay, now I may need to get more room, but I'm going to try to fit it right here. So I have 20.70 divided by 0.57. So I need to move my decimal place 2 to the right. So now, let's see, 57 divides into 207. 50 goes into 200 4 times. So let's see here. 4 times 57. So 4 times 7 is 28. Oh, that's going to be too much. Let's see. It goes in there 3 times. Okay, 3 times 7 is 21, carry the 2. 3 times 5 is 15, plus 2 is 17. So we're going to subtract. 7 minus 1 is 6. 0 minus 7, we need to borrow from here. So we have 10 minus 7 is 3. And then we're going to bring down this 0. Okay, 57 divides into 360. Let's see, 3, 4 times. Maybe 5. Yeah, I think 5 times. 5 times. 5 times 7 is 35. Carry the 3. 5 times 5 is 25. Plus 3 is 28. So let's see, we have 5, 10. 10 minus 5 is 5. 15 minus 8 is 7. So we could have gone there one more time. It's actually going there 6 times. Let's see here. Okay, 6 times 7 is 42. Carry the 4. 6 times 5 is 30. Plus 4 is 34. And we're going to subtract. So we have 10 minus 2 is 8. 5 minus 4 is 1. All right. Now we're going to bring down, we need to round to the nearest tenth. So we need 2 more decimal places here. So we're going to bring down a 0. So now 57 divides into 180. 1, 2, 3 times. 3 times 7 is 21. Carry the 2. 3 times 5 is 15. Plus 2 is 17. Subtract, we've got 9. Bring down another 0. We need one more number. 57 goes into 90 one time. 1 times 57 is 57. And we could keep going on and on and on. But we got what we need to know, so we can know how to round this 10th place here. So we're rounding to the nearest 10th. So if we look here, we're going to round this place here. We look to the right, it's a 1. So we're going to keep this at 36.3. That's going to be our answer, 36.3. Okay? So just be very careful when you do your division and multiplication with decimals. Just be really careful with that. Okay. Number 9. Make an approximation based on the conversions given. I will give you the conversions on the test that you need. Round to the nearest tenth. So we're converting 5 kilometers to miles, and they tell you that 1 kilometer equals 0.621 miles. So I'm going to go from 5 kilometers times, I want it to convert to miles, and I want the kilometers to cancel out. So that means we're going to take this information and put it here. So I'm going to put the 1 here for the kilometer and 0.621 for the miles. And the reason why I put the miles on top, because I want for the kilometers to cancel out, and I'll be left with miles, which is what I'm converting to. So I basically have 5 times 0.621. So I'm going to just take 621 times 5. And then I'll go back and add the decimal values in there. So 5 times 1 is 5, 5 times 2 is 10, carry the 1, 5 times 6 is 30, plus 1 is 31. But I have to go back and add 1, 2, 3 decimal places. So 1, 2, 3 decimal places. So it's going to be 30.105, but I'm rounding to the nearest tenth. So this is the 10th place here. I look to the right, it's a 0, so it's going to round to 3.1. If this number that I pointed to was 5 and up, we would round the 1 up. But it's not, so we're going to keep it exactly where it is. So it's 3.1 miles. Okay, number 10, solve the formula for the specified variable. I have I equals P R T, which is P times R times T. And I want to solve for T. So here's my, let me write this a little bigger. I equals P R T. And I'm solving for T. So I want this T to be by itself. So right here I have P times R times T. To get T by itself, I'm going to divide by PR. So the P and the R can cancel out. But if I divide by PR on one side of the equation, I must do it to the other side as well. So the P's cancel out, the R's cancel out, and all I have left is T equals, on the left I have I divided by PR. And that was my goal, was to solve for T. That's my final answer. T equals I divided by PR. And you could say T equals I divided by RP. That's the same thing. That's probably the answer that we're going to have on the test. No need to rewrite or rearrange the variables. Okay, number 11. Solve the inequality, graph the solution set, and write it in its integral notation. So just like if I were solving an equation, I'm going to move all of my variables to one side of the inequality and all of the constants to the other side. So this is my kind of line that's dividing my inequality. So I want to move 4x to the other side. So I'm going to subtract 4x. But I have to do it on the other side as well. So I'm going to have 6x minus 4x is 2x. I'm going to bring down that plus 9 is greater than or equal to positive 3. And now I'm going to subtract 9. So I'm going to have 2x is greater than or equal to 3 minus 9. I have different signs, so I subtract and take the sign of the larger number. So the larger number is 9, so it's going to be a negative, and then 9 minus 3 is 6, so it's going to be negative 6. So now I have 2x is greater than or equal to negative 6. And I want to solve for x. I'm going to divide by 2 on both sides. So 2x divided by 2 is just x is greater than or equal to negative 6 divided by 2 is going to be negative 3. So now it says to graph the solution set. I'm going to graph it here. Now I'm going to have negative 3 in the middle. So all of my values greater than negative 3 are to the right. And then it's greater than or equal to. So I'm going to use a closed circle. And I'm going to shade to the right. Now remember, greater than or equal to, or less than or equal to, use a closed circle. And then greater than or less than, use an open circle. So this is my graph here. That's my graph. And an interval notation, so remember on the number line, the farthest left is represented by negative infinity, and the farthest right is represented as positive infinity. So now, if I'm using interval notation, if I use a closed circle, I'm going to use a bracket where that value is. And if I have an open circle, I'm going to use parentheses where that value is. So for this graph, I always, whenever you're writing interval notation, you always write it left to right. So starting from the left, my graph starts at -3. And it's a closed circle, so I'm going to have a bracket and start at -3. And the solution is all the values greater than -3. So it goes all the way to positive infinity. Now you always use parentheses by negative or positive infinity because it never stops. So you want to use parentheses to kind of represent that it's going on and on and on forever. So your interval notation will look like this. So it's very helpful to graph the solution before writing it into interval notation. Okay. Number 12. Solve the compound inequality, graph the solution set, and write it in interval notation. I don't think this should be on this particular test, but we'll go ahead and work it out. Okay, so I'm going to solve for x. I'm going to subtract 3 on all sides. So on the very left side, I have -12 minus 3. I have the same sign, so I add and keep the sign. -15 is less than or equal to bring down that -3x. 3 minus 3 canceled out, and I have less than -6 minus 3 is -9. Then I'm going to divide by -3 everywhere. Now, when you divide by a negative in an inequality, you must flip the inequality sign. So this first sign is going to flip the other way, and this next sign is as well. So now I have -15 divided by -3 is +5 is now greater than or equal to x, which is greater than +3. Okay, so on a graph, let's see, I'm going to flip this the other way. This should not be on this test. We're not going to have compound inequalities on this test. So maybe this will be an extra credit problem because you actually have 26 problems and you really only need 25. But we'll go ahead and solve it. I want to put the smaller number first. I'm going to put 3. I'm going to write this compound inequality and just kind of flip it over. Such 3 is less than x, which is less than or equal to 5. So I have 3 and 5. I'm going to call this a bonus extra credit problem. Okay, so we've got at the 3, it's just less than, so we're going to use an open circle. And then at the 5, we have less than or equal to, so we're going to use a closed circle. So x is between 3 and 5, so we're going to shade in between here. So the interval notation will look like this. We're going left to right, and we're starting at 3, and we're going to use parentheses. And it goes all the way to 5 with a bracket. So this is like a bonus question. This is not going to count towards your grade. So I'm going to probably remove it from your actual test, but I'll still work it out. This is really an intermediate algebra problem. Okay. 13, solve. So we have the perimeter of a triangle. Let's draw this triangle. So the perimeter is 52 centimeters. So perimeter means that you add all the sides. That equals the perimeter. Okay, the perimeter of a triangle is 52 centimeters. Find the length of its sides. If the longest side is 7 meters longer than the shortest side, and the remaining side is 3 centimeters longer than the shortest side. So we're comparing all of these sides to the shortest side, so we're going to make the shortest side represent x. So we'll just say the shortest side is x. So one side is 7 meters longer than x, so we'll say this is 7 plus x. And the other side is 3 centimeters longer than x, so we'll say it's 3 plus x. So again, the perimeter means you add up all the sides. So x plus 7 plus x plus 3 plus x, all of that equals 52. So if we're adding these expressions, we can actually just drop the parentheses. So it's 52 equals x plus 7 plus x plus 3 plus x. So let's now combine all of our like terms. So we've got x plus x plus x is 3x, and then 7 plus 3 is 10. So I have 52 equals 3x plus 10. And then to solve for x, I need to get the x term by itself. So I'm going to subtract this 10 on the other side. So I'm going to have 52 minus 10 is 42 equals 3x. And then I'm going to divide by 3 to solve for x. So I have 42 divided by 3. So 3 divides into 4 one time. 1 times 3 is 3. Subtract and bring down the 2. Then 3 goes into 12 4 times. 4 times 3 is 12 with no remainder. So x equals 14. Now, let's see. So x is the shortest side. So the shortest side would be 14 centimeters. The medium side would be 3 plus x. So 3 plus 14 is 17. And then the longest side is 7 plus x. That'll be 7 plus 14, which would be 21. Okay? 14. Solve the problem. Midtown Antiques has found that sales have decreased 3% from last year. Sales this year are $172,180. Find the amount of last year's sales and round your answer to the nearest dollar. Okay, so let's see. So we have find the amount of last year's sale. So we have last year's sale minus 3% of last year. That equals this year. That's what this statement is saying here. Sales have decreased 3% from last year, and they are now, whatever this year is equal to 3% less than last year. So that's what we have here. Let's put some variables here. So it says find the amount of last year's sales. So whatever you're looking for, that's your variable. So we're going to find the amount of last year's sales. That's your variable there. So it's going to be x, it's going to be here, and x there. So it's x minus 3% of x equals this year. Oops. So what's this year's sales? That 172,180. So $172,180. Now, how do we find 3% of something? So to get 3% of something, we have to change that 3% to a decimal. So that'll be 0.03. And then we multiply that 0.03 times x. So we have x minus 0.03 times x equals $172,180. So x is the same thing as 1x. That's basically 1 minus 0.03. X equals $172,180. So what's 1 minus 0.03? It's going to be 0.97. 0.97x equals $172,180. And so we're going to divide 97 to solve for x. I'm going to actually get some extra paper here. Where did that go? I need that to be down here. Let's see. Okay, let me see here. One sec. All right, let's keep going. Okay, so I have 0.97 is going to be divided into 172,180. All right. All right, so we're going to move the decimal 2 to the right. We're going to move it 2 to the right as well. Okay, so here we go. 97 can divide into 172. 2 times 97. 2 times 7 is 14. Carry the 1. 2. Oh, that's too much. So let's only go in there 1 time. So 1 times 7 is 97. We're going to subtract. So 12 minus 7 is 5. 16 minus 9 is 7. Bring down the 1. Okay. 97 goes into 751. I'd say 7 times. 7 times 97. 7 times 7 is 49. Carry the 4. 7 times 9 is 63 plus 4, 67. Subtract. We've got 11. Carry, borrow from here. 11 minus 9 is 2. We need to borrow again. 14 minus 7 is 7. Bring down an 8. 97 goes into 728. 7 times. And we know that 7 times 97 is 679. We're going to subtract again. So 18 minus 9 is 9. Borrow again. 11 minus 7 is 4. Bring down at 0. 97 goes into 490. 4 times. 4 times 7 is 28. Maybe 5 times. Yeah, 5 times. Oh, geez. Here we go. Let's say 5 times. Let's say 5 times. 5 times 7 is 35. Carry the 3. 5 times 9 is 45, plus 3 is 48. Subtract, that's going to be 5. Bring down a 0. And we're going to just do this all the way to the end. 0 and then 0. Because 97 goes into 50. 0 times 97 is 0. And if you did it again, bring down another 0. Same thing. So, and we're rounding to the nearest dollar. So if we kept going, we would keep having another 0. So the answer is going to be x equals 177,500. That was the sales for last year. Okay? All right. Okay, let's keep going. Find the unknown value. So we've got $700 interest is paid when $3,500 is borrowed at 4% simple interest. Find the time for the loan. So we're going to use that simple interest formula, which is interest equals principal times rate times time. So the principal is the amount that you borrow. So that will be that 30,500. The rate is your percent. The time is the amount of time, which is what we're looking for. And then the interest paid is I. So in this case, I equals 700. P equals 3,500. And R equals 4%, which will be 0.04. And we're solving for time. So if we solve this for t first, we divide by PR, then I have I divided by P times R equals T. So we can plug in our values. So I is 700 divided by 3,500 times 0.04 equals time. All right. So we can actually simplify a little bit here. We can cross out those zeros, and 7 can divide into 35. 5 times. 5 times 7 is 35. So we can reduce 7 over 35 to be 1 over 7. So it's actually like saying 1 over 7 times 0.04. That's a lot easier to divide. So I'm going to have, let me actually add another page. I didn't want to do it right there. I want to do it right here. There we go. Okay, so 7 times 0.04. Well, 7 times 4. 7 times 4 is 28. But I have to move that decimal 2 places, so it's going to be 0.28. So I have t equals 1 divided by 0.28. And then I have 1 divided by 0.28. So I'm going to move the decimal twice. So 28 goes into 100. 1, 2, 3. Let's see, 30 goes into 100 3 times. 3 times 8 is 24. Carry the 2. 6 times 2 is 6, plus 2 is 8. And subtract. So I'm going to have 16. Bring it down to 0. 28 goes into 160. 2, 5, 6, 7. 6 times 8 is 48. Oh, a little too much. 5 times. 5 times 8 is 40. Carry the 4. 5 times 2 is 10, plus 4 is 14. Subtract. And then how much are we rounding by? It doesn't say. Okay. Let's do one more. 28 goes into 200. Let's say 6. That's 140 plus 28. So 6 times 8 is 48. Carry the 4. 6 times 2 is 12, plus 4 is 16. Yeah, I can go one more time. So I thought, let's try 7 times. 7 times 8 is 56. Carry the 5. 7 times 2 is 14, plus 5 is 19. Subtract, we have 4. Okay, so we're going to stop there, and then let's round this to the nearest tenth. So t would equal, it's 3.57, so that'll be t is about 3.6, so about 3.6 years. Okay? Okay, now let's get to some graphing. Plot the given point in a rectangular system. So we have -3, 0. So we're going to plot this ordered pair. So all ordered pairs are of the form x, comma, y. So the horizontal axis is your x-axis, and the vertical axis is your y-axis. So at -3, 0, so that means your x-coordinate is -3. So we're going to start the origin and go 1, 2, 3 to the left. And your y-coordinate is 0, so we're going to go up and down 0. So this will be where -3, 0 is. Review. In about 15, 20 minutes. Okay. All right. Number 17. Determine whether, where'd it go? Determine whether the ordered pair is a solution of the given equation. So in order to do this, you're going to plug in your ordered pair in for x and y. And if you get a true statement, it is a solution. If you get a false statement, it is not a solution. So remember, it's x, comma, y. So that means that x equals -2 for this problem, and y equals 3. So I'm going to have 4 times -2 plus 2 times 3 equals -14. Okay, so 4 times negative 2 is negative 8. Positive 2 times 3 is positive 6 equals negative 14. Negative 8 plus 6, we have different signs, so we're going to subtract and take the sign of the larger number. So that'll be a negative 2 equals negative 14. That is definitely not true. So this would be determine whether the ordered pair is a solution. No. And what that means is that if I were to graph this line here of this equation, 4x plus 2y equals negative 14, the point negative 2, 3 would not be on the line. So this is not a solution to the equation. So now we're going to find 3 ordered pairs by completing the table, and then we're going to use the ordered pairs to graph the equation. Okay, so we have y equals negative 3x minus 6. So we're going to plug in these values in for x. So negative 1, we're going to plug in for x and get our y. So we have negative 3 times negative 1 minus 6. That's going to be negative 3 times negative 1 is positive 3 minus 6 is going to give me negative 3. So we have the point negative 1, negative 3. So negative 1, negative 3 would be here. Let's do the next x coordinate. Negative 3 times 0 minus 6. Negative 3 times 0 is 0 minus 6. And then 0 minus 6 is negative 6. So when x is 0, y is negative 6. And let's do the next one. So we have negative 3 times 1 minus 6. Negative 3 times 1 is negative 3 minus 6, which equals negative 9. So when x is 1, my y is negative 7, negative 8, negative 9. Negative 9. And so this would be 3 points on my line. So I'm going to connect the dots.
Okay, so I'm going to have to narrate over my writing because I did not record my voice before. So this is number 19. We're going to find the intercepts and then graph the linear equation. So we'll start by finding the x-intercept, and to find the x-intercept, we make y equals 0. And so what I'm going to do is plug in 0 in for y and solve for x. So I have negative 12 times 0 is just minus 0. And then I have negative 4x minus 0 equals 12. So that leaves me with negative 4x equals 12. I'm going to divide by negative 4 on both sides. And then I'm left with x equals negative 3, because 12 divided by negative 4 is negative 3. Now I found my x-intercept. Now I want to find my y-intercept. And so you see that I plot the x-intercept on the x-axis, and that ordered pair would be negative 3, 0. Now let's look at the y-intercept. So to get the y-intercept, we make x equals 0. So I'm going to plug in 0 in for x and solve for y. So I have 0 minus 12y equals 12, which will give me negative 12y equals 12. And then to solve for y, I'm going to divide by negative 12. And 12 divided by negative 12 will give me negative 1. So the y-intercept is going to be negative 1. So I would plot my intercept at negative 1 on the y-axis, and that ordered pair would be 0, negative 1. And then once I have my 2 points, I would connect the dots and graph the equation. Okay, the next problem, number 20, find the slope of the line passing through the pair of points, or state that the slope is undefined. So for this problem, when I have 2 points and I have to find the slope of a line, I'm going to use the slope formula, which is m equals y2 minus y1 divided by x2 minus x1. So we can label our points. So the first point we'll label those coordinates x1, y1, and the second point will be x2, y2. So now we're going to plug in our coordinate points. So we have y2 minus y1, so it's going to be -4 minus -4. And then at the bottom, x2 minus x1 will be -8 minus -3. So now I have minus a negative, so that's the same thing as adding the opposite. So it's actually going to give me -4 plus 4, which will equal 0. And then at the bottom I have -8 minus -3. Minus a negative changes to add the opposite, so I'm left with -8 plus 3, which will give me -5. Now 0 divided by, here we go, 0 divided by a number will equal 0. Now remember, a number divided by 0 is undefined, but 0 in the numerator would just simplify to 0. So the slope of this line is 0. Okay, 21. Find the slope of the line or state the slope is undefined. So we're going to count our rise over run to identify the slope by looking at the line. So remember that you can know that our slope is going to be negative because it's going down from left to right. So slope is the same thing as rise over run. That's what the slope of a line represents. And that tells us to go from one point to the other, how much we move up and down divided by how much you would move left to right. So we're going to go from this point to the next one that I marked here. And so we're going to count our rise, or how much we go, in this case, down. So we're going to go down 6 spaces, 6 units down. So that's going to give us -6 for our numerator. And then for the denominator, which is our run, we're going to count 6 to the right, 6 units to the right. So since it's to the right, it's going to be a +6. So now -6 divided by +6 gives me -1. And so -1 is going to be our slope. Now we could also count in the other direction. It would still give us the same answer. If we went from the bottom point to the higher point, we would count 6 units up, which would give me a +6 in the numerator, and then 6 units to the left, which would give me a -6 in the denominator, but that still would equal -1. So either way, we still get the same slope. In this case, the slope is -1. Okay, 22. Find the slope of the line, and we are given an equation. So when you're given an equation and they ask you to find the slope, the way that you do that is to rewrite the equation into slope-intercept form. And so slope-intercept form is y equals mx plus b. The m is your slope and the b is your y-intercept. So we're going to take this equation here and we're going to solve it for y, get the y by itself. And so to start, we're going to subtract 5x on both sides. So we're going to be left with -2y on the left equals, now since I want it to be in slope-intercept form, I'm going to write that x term first. So I'm going to say it equals -5x minus 8. And now I'm trying to get y by itself, so I'm going to divide everything by -2. So on the left, I will just have y equals -5 divided by -2 is +5 over 2 x, and then -8 divided by -2 is +4. Now this is my equation in slope-intercept form, so now I can look at the equation and find the coefficient for the x term, which is your m, so the slope is going to be 5/2. Okay, 23. So find the slope m and the y value of the y-intercept b of the line with the given equation. So we're going to do the same thing. We're going to recall the slope-intercept form, which is y equals mx plus b. And so we're going to put our equation into slope-intercept form so we can identify the slope, which is m, the coefficient for the x term, and then identify the y-intercept, which is b, the constant. So to start getting it equal to y, we're going to subtract 10x on both sides to get rid of that 10x. So I'm going to have y equals, and then I'm going to write negative 10x first because I want it to be in slope-intercept form, and then write our minus 3. So now I can identify what the slope is because the slope is going to be negative 10. It's the coefficient for your x term. And then the y-intercept is your b, so in this case it would be negative 3. Remember, always keep that sign in front of the term. Okay, number 24, graph the linear equation using the slope and y-intercept. So the slope is your m, and in this case the slope of this line is negative 2. And so remember that slope is a ratio of rise over run, so let's write negative 2 as negative 2/1. And then for your y-intercept, you don't see a number, so we'll say that's 0. It's like saying plus 0, so the y-intercept here is 0. So in order to graph using slope-intercept form, we're going to begin by plotting the y-intercept, the b, which in this case is 0, and then move with the slope. So beginning at 0 on the y-axis, we're going to move with the slope, negative 2/1, which remember slope means rise over run. So beginning at the 0, we're going to go down 2 and to the right 1. Down 2 to the right 1. Down 2 to the right 1. We can do this as many times as we need to get our points to make a nice straight line. Okay, 25. To the nearest dollar, the average tuition at a public 4-year college was $3,011 in 1997, and then it went up to $3,230 in 1999. Use the ordered pairs 1997, 3011 and 1999, 3230 to find and interpret the slope of the line representing the change in tuition to the nearest dollar per year. So we're going to use the slope formula, which means we're going to subtract our y values and divide it by the difference and subtract the x values. So we have 3230 minus 3011, and so we're going to put 1999 minus 1997 in the denominator, and then we're going to subtract and simplify this expression. So 3,230 minus 3,011, so we need to borrow from the 3 and make that 0 a 10. 10 minus 1 is 9. 2 minus 1 is 1. 2 minus 0 is 2. And then 3 minus 3 cancels out. So we have 219 at the numerator. And then, of course, 1,999 minus 1,997 equals 2. And so now we want to actually divide 219 divided by 2 to figure out how much it increased per year. So we can start by dividing 2 into 2. 2 goes into 2 one time. And then if we multiply and then subtract, we'll have 0 and it'll bring down the 1. 2 divides into 1 0 times. 2 times 0 is 0. If we subtract, we have 1 again and bring down the 9. And then 2 divides into 19 9 times, because 9 times 2 is 18. And if we subtract, we have 1. We have a remainder, but let's get what the decimal value would be so we can round this to the nearest dollar. So if we add a 0, 2 goes into 10 5 times. If we go back and multiply, we will have a 0 remainder. So the answer, 219 divided by 2, is 109.5. But since we want to round this to the nearest dollar, that's going to round up to 110. So the tuition increased by $110 per year. So now the last question on this review is going to be a problem talking about sets. So we want to list the elements of the set. So we have 2 sets here, and they are being connected using the intersection symbol. So we want to include all of the elements that are in both sets. We want to look at where those sets overlap. We want to include those into the set that we're going to write. So if you notice, the only elements that are in both sets would be 8, 17, and 24. 3 is only in one set. 14 is only in the first set. And 27 is only in the last set. So the answer for this would be 8, 17, and 24, because it's only where they overlap. So now finally, just to remind you, Test 2 is in the testing center right now. The deadline is going to be Tuesday, November 13th, because Monday, November 12th, the Osceola Testing Center is closing early for a staff meeting, and I figured some students do take their tests in the evening, so I wanted to give you enough time just in case that would have thrown off your schedule. So I pushed back the deadline for Test 2 until Tuesday, November 13th. Remember, you cannot use a calculator, and you will have 2 hours to complete this test. If you have any questions at all, please feel free to come down to the depot to get some extra help. You can use Smart Thinking for free online tutoring, and take that Test 2 review multiple times to get yourself more and more comfortable with what's going to be on the actual test.